headphone or
Okay.
plug-in.
I will, because I'm using a USB headphone, so it shouldn't give you the buzz. Maybe something else is the problem.
যে নয় হ্যাঁ এখন চলে গিয়েছে।
Oh, sorry, it's worse now.
সো এই যে নয়েজ থাকে না একটা, ওই নয়েজ আসছে আর কি হেডফোনের। হ্যাঁ ইটস বেটার নাও আর কি।
Is it?
So it was a couple of seconds ago.
Interesting. I actually practically didn't do anything. I mean, I just unplugged the USB and plugged it back in.
I mean বোঝা যাচ্ছে কথা, so I mean we can make it work.
Yeah. Let me try to see if there is anything that has to do with the settings. If not, then the settings look fine. It's on USB and I'm on USB.
If you have your smartphone you can use companion mode, so ফোনের মাইক ইউজ করে করতে পারেন যদি, কিন্তু আমার মনে হয় না প্রবলেম হবে,
No,
শোনা
I don't
যাচ্ছে
have a
কথা।
suitable headset for a smartphone. I do have it next to me, but I don't have one as such. Okay, let's live with this. So, we'll collect your attendance at 11 a.m. Okay, 5 minutes from now. Let's get everything set by that time. All right. Today we are going to discuss about technology progression, how the human role changes, okay, the dynamics of human role, and we'll talk about how is the nature of future work, okay. Now, before we proceed, do you have any question from the previous discussion? Any question? See, now that you know that this is an online lecture, so this is imperative that anytime you receive a question, at least one or two of you would respond. Otherwise, I would suspect the network connection that I am snapped out. ঠিক আছে?
Yes, sir.
Good. What did we discuss in the last lecture? We talked about in the last lecture slide, in fact, lecture slide 5, we discussed about production functions, how some of the principles, we talked about 10 principles of economics from the point of view of engineering economics, okay? So now let's try to dive in how the role of people changes. You remember seeing this kind of autonomous robots, robot vehicles as pet project or maybe capstone projects displayed at the plaza area, fondly mentioned as, robot competition, autonomous vehicle competition, track tracer robots. Have you seen this type of
Yes,
things?
sir.
जी सर।
Now, these type of robots or autonomous vehicles have been out there for many years now. It's like since late 1990s, students are building these as their capstone projects. Faculties are doing research. The whole intention was to produce and deploy vehicles so that you would not require a driver on it. Okay? But now, fully autonomous vehicle, which people envision something like this, which will detect vehicles in front of you, behind you, full of sensors, providing highest class security, and able to maneuver in the most tricky and complex environments, exactly mimicking the capability of a human driver. Has that really materialized?
No.
Not yet, sir.
There are a handful of cities, maybe 4 or 5 cities across the whole world, that has the infrastructure to accommodate an autonomous vehicle. Okay? If you do not have infrastructure suitable for autonomous vehicles, your vehicles would be unable to run across the streets of Dhaka, for example. Why? Because envisioning and producing a prototype and a production grade product, an usable product, has a journey. Okay? It has a journey of growth and development. Now, in this journey, there are few factors that are in play, and we discussed this in the earlier lecture. If this is your output, you know that it depends on, it's a function of how much effort you're putting in and how much capital investment have you done and how much of human capital it's invested in. And additionally, you have the ideas, how ideas are infused in, and in addition, you have how decisions are made. Okay? Which feature to be added, when to be added, and really it's going to be perfect or not. All of these decisions, right? But the question is, sometimes when you embark on this journey, you start seeing that in the previous lectures you have seen how the amount of human capital required reduces over time. Okay? How you may have to increasingly depend on capital investment. How your idea becomes very pivotal. Okay? So the relationship between these parameters play a significant role whether a prototype like this will metamorph into a viable and reliable product or not. Okay? Because you know the amount of human capital you have, this influences your idea. And human capital also influences your decision. Okay? And later on, these two are also dependent. Okay? If you're reducing human capital, you may have to increase labor. At some point, your labor will also reduce. So it's important to understand the interrelationships between these parameters. Okay? And how these parameters are going to evolve over time as the technology is progressing. As we know that technology is progressing. So how this progression is influencing these L, K, H, A, and D. Okay? This is the idea of this discussion. Now, why is it important? Because you have seen over time that whenever there is new invention, there is creation of new jobs. And we touched on this particular topic earlier. Let's try to discuss this before we move on to anything else. How does jobs originate? How does job originate? Whenever you have a new product, let's say you did not have computers, let's say you did not have personal computers, but personal computers are invented. Okay, and then what happens? It requires some operating system, OS. For OS, you require, to run the OS, you require applications, many applications. So application requires somebody to develop it. So it brings new tasks, and as a result of which you keep on seeing the developers, software developers, right? So the job role of software developers came into existence because of invention of PC. Okay, this is how jobs originated. Then how can jobs disappear? If a certain invention is producing efficiency, then jobs can disappear. For example, earlier you needed to have a lot of typists in the offices. There used to be a job role for typist. Okay, there used to be job role for office secretaries. But now when you had computer keyboards, the job role of typist started to disappear. Okay, and very soon, while you have your email assistant, your scheduling assistant, all of these are from AI, you are beginning to see disappearing of office assistant jobs. Okay, so whenever you have feature invention, you are going to see consequent growth of job. Whenever you're going to see efficiency invention, you are going to see your jobs are going down. It's disappearing. Okay, now if you look at this, there has been significant level of automation, significant invention that automates factories, automates how people do jobs. Okay, for example, there used to be time before the age of internet. If you wanted to create awareness about a product, you would print leaflets, you would produce brochures. Now after that, you have inventions of internet. You produce websites which does not require copying of papers, which does not engage people distributing those leaflets. Instead of that, you have the websites that is automating the job of distribution of information. So whenever you have automation, you have reduction of people engaged into those jobs. And you can see there are millions of investments across many different countries that wants to enable automation. See the investment in China, okay, significantly higher than that of USA. Automation. Why do you want to automate? Because if you automate, you have possibility of scaling up your production, and also you have possibility of reducing the cost. That's why you automate. Now when you automate, you might be reducing one type of job, you're reducing, but definitely you are going to give rise to the job of R&D and the engineers who are building the robots. Okay, so this type of shift in the job is inevitable. Now the question is, if you have just two actors two broad categorized actors in a production system. If you want to categorize H, L, A, and D, all of them in labor category. That means you need to engage people. Okay? And whatever you don't engage from people is capital K. So in a broad category, you have to engage these two types of inputs to produce some kind of output, to execute the task. Okay. So the question is, if you have multiple different types of jobs to be done, which job you allocate to the labor and which job you allocate to the question, that's what you have to decide. Okay, either humans will do something or the machines will do something. That way you have the production. Okay, because even if you want to keep your same level of production, you still can consider whether you are going to give more responsibility to machines or to humans. We have discussed about isoquant line in the previous lectures. Remember that? Isoquant lines. Isoquant lines, if this is an isoquant line, on the vertical axis you have capital, this is labor. Isoquant line tells you the combination of capital and labor which produces the same output. Okay, so you can have very lot of labor, capital. You can have very little amount of labor. Let's say this is 20. This is the arbitrary number. This is 80. Whereas at this point, whether you are at point A or at point B, you are using maybe I don't know, 100 labor, and down here you have 20 capital. Essentially, you are producing the same amount of output. Okay. The question is, if you are producing the same amount of output, what amount of human versus what amount of capital you are going to use? In the previous discussion, we talked about this is decided by market. Okay, we talked about this. Remember that? We said when you are in the market of Bangladesh, we have a lot of cheap labor. So companies tend to hire more of the laborers. They tend to operate in a point similar to B. If the company encounters expensive labor forces, whereas machine is cheaper, then they tend to operate in this. For example, you'd find Japan tend to operate at point A, and Bangladesh would be operating at point B because we have cheaper labor. Now, because market is one of the ingredients, it's true, but there is another factor. Another factor. The factor is, can you allocate all of the jobs that humans do? Can you allocate all of them to machines? Allocation. Is the allocation possible?
No, sir.
No, sir.
Not always. For example, if you require to design, let's say, a creative architectural design, which requires human touch, would you be able to have a machine, maybe an AI, producing a nice architectural design? Maybe it will produce, but it will lack human touch and it may not see enough appreciation. So it's not that all kinds of jobs can be allocatable to machines. Okay, so it depends on the capability that are in the machines. Okay, you see that. Now if you look at what are the capabilities that we have as humans, how we use those capabilities. You can look at the roles that you and I can engage in. Let's say, consider yourself as sitting here. Either you engage as far as production is concerned, you invent the product, that means you design the product, or you are in the production system. Somebody designed it, you are making multiple copies. Okay? Somebody designed a smartphone, this is how it should be, and you are making multiple copies. Okay? You are making multiple copies, but you're not designing. That is also a type of engagement. However, the third kind of engagement, as far as product is concerned, is the usage of the product. Whether you do the usage for your personal consumption, or you use it to produce some other products. Okay? Doesn't matter. This is another role which you are engaged in. Okay? So there are three types of broadly categorized roles which you can undertake. And to accomplish these roles, I just remember that we haven't taken your attendance yet. So let's finish this slide, then we'll take your attendance. To accomplish these roles, you require to have certain capabilities. So all the capabilities that you have, you can broadly categorize these capabilities into three. Category number one are some capabilities which you are born with. Okay? Nobody had to teach you how to smile. Okay? Nobody had to teach you when to laugh when you hear a joke. Okay? These are innate capabilities. If you look at the floor, you can readily say that if this is dirty or a clean floor. Okay? These are all innate capabilities. In fact, you have a total of about 52 types of innate abilities, which many, psychologists and professional researchers have found out in individuals. Okay? You are just born with these. There is another type of capability which you gain when you are exercising these innate abilities. You watch how a certain thing is getting done. By watching it, you learn it. You learn how a computer is operated. You gain an experience. You continue to cook rice for many, many times, and you learn how to best cook rice. Okay? So this type of learning is based on experience. You gain experience, and that gives you special capability. Somebody cooks biryani that tastes like awesome, whereas some people, they follow the same recipe, but the taste is not that great. It's true, right? You have seen this. So now, the difference between a very experienced cook and an inexperienced cook is the tacit capability. Okay? Usually, why do you call it tacit? Because this type of capability largely remains undocumented. Are you getting it? Your undocumented capability is called your tacit capability, and it's derived from experience. Now, some of these capabilities are written down for greater distribution. For example, somebody learns how to do calculus. Okay. Somebody learns that if you add 2 fingers plus 2 fingers, that gives you 4 fingers. So he writes that down and teaches it to somebody else. So if a little child who is unaware of counting, he learns how to count and he can count 2 plus 2 equal to 4. Okay. This used to be somebody's experience because he matched 2 fingers together. He had 2 fingers together, 2 plus 2, he counted it to 1, 2, 3, 4, and he passed on this knowledge to a child who did not know how to count. So now the child can count, and this knowledge is codified knowledge. The knowledge was codified, taught in universities, schools, colleges, and written in books, training materials. So these are usually complex knowledges converted into codified format for better consumption and education. Okay. Now, when it comes to converting these capabilities, this is number 3. Now, either one of these capabilities will be utilized in these roles in different proportions. Okay. For example, if you want to use a, let's say, I don't know, what could be a good example? You bought a scanner. Okay. You bought a scanner, and the scanner contains a manual. So that manual is a codified knowledge, and you learn how to read. So you are using your codified knowledge to read the manual and use the product, okay, for consumption. Now, as you use the product for many times, you gain some experience to how to use it. If you have a rice cooker, okay, some of the rice cookers, maintain the, temperature and water level automatically. Some of them don't. Okay. For those, if you are using the same cooker many times, you know how to best utilize it, how much rice and how much water you have to pour in. Okay. That way you gain in tacit ability, and your tacit ability is in utilization while using the product of rice cooker. And at the same time, you are using your vision and your sense of smelling, and also your hearing, to understand when is the rice cooker is lit up, it's cooking it, when the cooking is done, it's in warm mode. Okay. So you are engaging all these capabilities, all 3 of these, to accomplish this one task. Now, the degree of engagement of these capabilities, maybe you are using, in the rice cooking, you're using only 1% of your innate capability. Maybe you are using 10% of that from your tacit capability. And codified knowledge, you learn how to plug in the rice cooker and, uh, proportion your content of water and rice. These are all written in book. You have spent like 89% of your codified knowledge to cook the rice. Okay. So similarly, depending on the type of work, you have different degree of capabilities engage into that particular role. Now imagine that you are sweeping the floor, or you're driving. Let's say you are driving. You're driving a vehicle. You have a bike. How much codified knowledge you require to ride a bike? How much tacit knowledge is required? How much innate capability is required? Or maybe you are, let's say, sweeping the floor. How much of education do you require to sweep the floor? Are you there in the class?
Yes,
Yes,
sir.
sir.
So you require very little amount of formal knowledge to become a cleaner? And do
Yes,
you
sir.
have to gain a lot of experience to clean the floor?
Yes, sir.
Not
Experience
really. To
gives
some extent, maybe.
advantage, sir.
You require experience, okay, to make it faster, maybe. But there is an extent of that experience. If somebody is experienced, very experienced cardiac surgeon, compare his depth of experience. Let's say he has been doing cardiac surgery for 30 years and he has more than 10,000 successful cardiac surgery record in his logbook. Compare his level of tacit capability and compare a cleaner who has spent 30 years of cleaning a factory floor, cleaning a household, okay, and compare his tacit experience. Which one will be bigger, higher?
The cardiac surgeons.
The cardiac surgery surgeon will have definitely higher level of tacit ability, for sure. Now, if you compare, so it varies. Now, if you compare the amount of innate ability, your vision, your physical labor, your ability to sense if the floor is clean or not, if it's dry or it's wet, if it requires, additional cleaning agent or not, if you require to deploy a machine or not. These are all dependent on your vision, your sense of thinking, your smelling, your hands. All of these are innate capabilities. Now, if you want to distribute how much of this 100% of cleaning, sweeping floor is dependent on different kinds of capabilities. You'll find that maybe 90% of the floor sweeping capability is dependent on innate abilities. Maybe you have, maybe, I don't know, maybe 6% tacit, and rest of it you require codified knowledge, because you might have to turn on a switch, you might have to turn on a vacuum cleaner, and so maybe you are using a broom, maybe a little bit of codified knowledge, okay, maybe 4%. So you can see that when a job is more manual and simple, that job tend to depend more on your innate capabilities. Okay, are you getting the point? Now, having understood this, imagine you are trying to delegate your job of sweeping the floor to a machine. Now, a mop is also a machine, right? You understand what is a mop? Mop ki jano to? That comes with a stick and it has a lot of fibers. This is the mop.
Yes, sir.
Okay. Now, if you consider a mop is a tool, is a machine, okay, then how much intelligence does the mop have? Can you ask the mop, go and clean it up yourself? Can you instruct it? You
No,
cannot.
sir.
You have to use your own vision, use your own capabilities, and continue to work with the mop. Okay, can you give me just a second? I have an interruption here, so I have to take care of it. Okay, so what if you automate the mop? So the mop, if it has a very low level of intelligence, then you have to engage most of your capabilities with it. But if the mop becomes intelligent, the machines, a mop is a machine which has this type of intelligence. This is a very primitive machine. The machines before 1900 used to be very primitive, devoid of higher level of senses and capabilities. Machines used to be like tools, like a screwdriver, a wrench, or like a lever, okay? Or maybe like a stone in the Stone Ages, or maybe a needle. These are machines, but the capabilities inside is very elementary. So after that, people realize that if you have to get your tools do more of the job, you have to infuse more of the codified knowledge and tacit abilities and innate abilities into the machine. Okay? The more of these abilities you infuse into the mop, the higher becomes the usability of the mop. So you produce devices like this. Have you seen this type of devices? Machines, tools? This is a vertical saw, mechanical saw. Okay, this is a drilling machine. This is a wood planer. Okay, this is a planing machine. Okay, so with this type of machines, you still have to engage your human level. The machine is giving you some of the codified capabilities. For example, if you're using a drilling machine, it can specifically drill a certain location with a certain diameter. Okay, but you still have to engage yourself physically. But what about this type of machines? This type of machines. Have you seen any one of these on videos? Four four-legged robots.
Yes, sir.
There are
Yes,
Chinese
yes, sir.
companies mass producing this type of devices these days.
Sir,
And these
India too.
in India also, right? You see these machines, they have a camera in their front, they can navigate, some vision ability. They can cross a terrain, and if you ask a complex task, it will accomplish it. So what do these machines have? These machines have much of this codified knowledge. It can have some of the innate capabilities, and you can also train them. For example, you can train your artificial intelligence to interact with you and take an inference out of a set of data. Okay, so the more of these capabilities you are installing in your machines, the machines become more useful. Okay, but is it always easy to install higher level of capabilities into machines? The degree of complexity to install higher level of capability in machines are not the same. Okay, do you agree with that? The capability of installing higher level of capability, abilities into the machines vary. If you want to install codified capability in a machine, let generally the complexity is lower. For example, if you want to train a calculator how to add 2 plus 2 equal to 4, that is an easy task. And calculators have existed since early 2000, early 1980s, not even earlier. Okay, even you had wooden calculators, right? So the capability of the complexity to produce these machine capabilities in the codified knowledge area is less. So that's why people have produced a lot of computers, calculators, and things that do the measurement. Okay, you'll see calculators are way better than humans in doing certain calculations. Regarding the next level, some abilities which are gained by your experience. I have another interruption. Just hold on a few seconds. Okay, so if you have to install tacit capability, tacit means based on experience, okay? If you have to train an autonomous vehicle how to navigate in a certain level of traffic, then you have to give a lot of training data from other autonomous vehicles, okay, to the AI of the autonomous vehicle, and that way it will get a lot of different scenarios, okay? The installing of tacit capability has medium level of complexity. However, installing innate ability, teaching a robot when to smile, okay, may not be that simple. All right. So innate ability quite often is very difficult to give in a robot. Okay. For example, you might find experienced drivers, maybe an old driver, maybe he's 60 years old, a bus driver. Okay. You will find that he is more reliable, he is better as compared to a driver which is only 20 years old. He is better than 20-year-old driver. How? Not because the 20-year-old driver have any worse reflex. Rather, a 20-year-old individual has better reflex, and he has more agility. Okay, in the face of accidents, he can take quick action. While 60-year-old has a very large reaction time. Okay, but still you'll find that these guys make less accidents and these guys make more accidents. Why? It's because these
Because
guys
they
have
are
more
they are
experience.
le-
They have more experience and they can sense. They can sense this is a tricky situation, so you'd better handle. An old sailor, although he is old and he doesn't have that fast reflex, but the old sailor has generated some sense, some innate ability which can help navigate a rough ocean better. Okay? So this kind of sense is very difficult to install in machine. Okay, unless you have that kind of sense installed in a machine, you cannot replicate, you cannot replace a human driver, a human sailor. Okay? So the degree of complexity of installing this kind of capabilities into the machines vary. And that's what decides what machine can be deployed in what role. And to make it even worse, some of the automation efforts, because people are trying to install more capability in machines so that they can offload humans. But this is the pattern. In multiple industries, the effort of automation found a very easy path if the automation is only automating the codified knowledge. Okay? Like you are automating the measurement device, taking automatic measurement. Or you are engaging a spreadsheet to do your accounting job. You have given all the formula and the computer is able to do the calculation. So it's easy to automate the codified knowledge. But when it comes to automating tacit knowledge, you require huge amount of data set, and quite often that may not be enough. So as you progress from codified to tacit, your progress slows down. And if this is your target of reaching 100%, sometimes it becomes so astronomically difficult that your 100% almost never reaches, it saturates. Okay, regardless how much you advance in digitization. Although if you are predicting here, if you're predicting the progress here, you might predict that by this time, let's say at T1, you expect your product would be fully autonomous, but T1 goes past, but you're still unable to reach your full autonomous setup yet. So this has happened in autonomous vehicle industry. That's why although Elon Musk said that he's going to have automation of all autonomous vehicles replacing all drivers, that didn't materialize yet. You have semi-autonomous, driver-assisted autonomous, driver-monitored autonomous, and so on. Okay. Now, how does that impact the degree of complexity to install capabilities in machine? How does that impact in the job market? Because after all, that's what we are monitoring. In the job organization, in the organization structure, you will find at the lower level many people. Okay. At the mid level, you will find less number of people, and at the top level, you have further less number of people. So it's rather like a pyramid. But if you look at the type of capabilities that the lower level people engage, you have just seen that at the lower level people require higher amount of innate ability, good vision and good hearing ability and faster reflex. These are important for a driver. Okay. A construction worker, he has to have good sense of balance if he is constructing something in the high-rise building. So these innate abilities are utilized in a very high extent, which is very difficult to replicate by machine. Whereas the codified knowledge, the education level for a low-level worker is not as high. Whereas if you go to the mid-level, you'll find the managers there. They're not expending a lot of effort in, physically, but rather they are doing a lot of managing decisions and calculations, you know. So these require a good amount of education. Like you have to become an engineer to become to run a power station. You have to become a software engineer to manage a cloud cloud data center. Okay, so you require more amount of codified knowledge if you are working in the mid level. But if you go to the top level, you require both of them almost on an equal par basis. Okay, but when you have this type of complexity, codified knowledge easily gets delegated to machine. So you are going to see more of this mid-level people. Let's say this amount of people, these jobs can be delegated to machines. These jobs can be delegated to machines. So your organization will not require this many level in the mid-level because the machines can do it. So you will see a flow of human roles from mid-level to lower level, and some of the mid-level will be moving on to the top level. Okay, that way your mid-level will be shrinking, and this has already shrunk. The lower level will stay the same or it will expand, and the top level sees similar kind of polarization. So this is how the job industry tend to be polarized because of automation of to gain your efficiency. Okay, automation is producing this type of job polarization. I think we should collect your attendance right now. Okay, let's do it, and let's do it. Otherwise, we'll be forgetting. Let's see if we have to log in back. Could you follow?
Yes, sir.
Okay. What happened? Okay. Now it's 3368. Okay, you may respond with your text chat box, or preferably you can respond with using your audio. Tasfikul Islam. Tasfikul Islam. Asmaul Islam.
Present, sir.
Shazneen Rahman. Shazneen Rahman. Fadia Shahadat. Fadia Shahadat. Hafsa Amin.
Present, sir.
Muhammad Hasibur.
Present, sir.
Sadman Ikram.
Present, sir.
Samun Abedin. Anika Said. Anika Said. Humaira Tabassum. Okay. Noshin Nawar. Noshin Nawar. Gazi Samira.
Present, sir.
Tasmiyat Hassan.
Present, sir.
Gazi Fatin. Gazi Fatin Zakia. Gazi Sahib.
Present, sir.
Azim Bishash. Azim Bishash.
Present,
Muhammad
sir.
Wajid.
Sir, Azim Bishash,
Is that Azim Bishash? Okay. Muhammad Wajid.
Present, sir.
Okay. Sadia Reza.
Present, sir.
Ridwan Islam.
Present, sir.
Tahshan Jamil. Tahshan Jamil. Faiza Akila.
Present, sir.
Marzana Tabassum.
Present, sir.
Fahim Hussain.
Present, sir.
Uma Banik.
Present, sir.
Karma Sonam.
Yes, sir.
Mahmudul Hassan. Mahajabil Noor.
Present, sir.
Mahir Shahriar.
Yes, sir.
Shamiul Alam.
Present, sir.
Mahfuzur Rahman.
Present, sir.
M.A. Rahman Junaid. Rahman Junaid. Shafiur Rahman. Shafiur Rahman. Samin Reza.
Present, sir.
Ghulam Mahiuddin.
Present, sir.
Shamsia Munira.
Present, sir.
Rahman is present, sir. Rahman is present.
Tazreen Alam.
Present, sir.
Khan Rumban.
Yes, sir.
Rafi Maisun.
Present, sir.
Ratul Hassan.
Yes, sir.
Okay, did I miss any?
Nothing that you're
Sir.
present.
Sir.
Simon
Sir.
Abdin.
Yes, Simon Owens.
Sir, 14.
14.
So Simon was the upperest.
Okay. Anybody else? All right. Submitting. Okay. So now you realize that if the automation kicks in, the type of job most people will lose will be in the middle area. For example, when artificial intelligence and the vibe coding became popular, which set of people will start losing job more? The developers, the testers, or the top level management?
Developers.
Because you may not lose the job, but you will require less number of developers in future. So the job in the middle level developer market will not grow, and it has a potential to reduce. So what's going to happen is many of the individuals, developers, they will have to either move to becoming a software architect, or they'll have to relegate. It's not relegation, I would say. They have to take the job of a software tester. I'm not saying software testers are really lowly paid. They may have high payment, but the type of work that they have to engage in is like, it's more about manual testing. Okay, you have to give a good feedback on detailed feedback on how a certain software is performing as a tester. So software tester job could be practically falling in the low level, okay? So this is the result of automation. Now, as you have AI in progress, it opens up the scope for becoming an AI engineer, right? So this is the idea. When the technology progresses, you will have new products introduced, or you will have introduction of new feature. Either one of these will give rise to new kind of task, and it will give rise to higher amount of labor and people. Okay? Humans will be required in higher number. However, when you want to gain efficiency, okay, you want to reduce your production cost, you want to automate certain things. Automate means you are not willing to stay dependent on humans. You engage robots, okay, as a result of which you are going to see reduction of jobs. And as you hear, fourth industrial revolution, which is built on top of the earlier three industrial revolutions, the fourth one is automating things. It's giving capability on machines so that the machines become really intelligent of this sort, okay? So as the machines are evolving, you are seeing the production cost reducing, and you are witnessing the fourth industrial revolution. As a result, you will see a degree of job polarization by countries. In the countries where you have more number of people, labor is cheap, you'll find that type of labor intensive job migrating to those areas. Bangladesh becoming the second in garment production is not because we are really good at it, but rather because we are economical at it. We have a lot of people, lot of labor at lower cost, okay? So that's why the jobs are polarized, garment jobs are polarized into our countries, okay? So country level of polarization effect will also be visible as we move forward in future, okay? So this is more or less today's discussion. You read through this text. The ICT capability is enabling remote jobs. For example, some hospitals in Thailand, they have a very strong remote telemedicine platform. So you'll find people across the world, they are seeking service from those telemedicine features. And because of ICT, many of these doctors and professional doctors' jobs have been located into one part of the world. Computer troubleshooting and fixing, updating, maintenance, these have already been homed into India. Now with the ICT capability, you can remotely fix many computers across the world and give this type of support, okay? So this type of polarization will be more in effect as we move forward. Now, what are the challenges we have as developing countries? We have to take advantage of this polarization. At the same time, we have to remember that this polarization is dynamic. We have a lot of garment companies in Bangladesh. Does not guarantee that we'll continue to have this kind of garment companies in Bangladesh, because maybe the automation is enabling human-like machines in the developed countries. So if they start replicating our human labors by their robots and are able to manufacture their clothes in their homeland, they will never want to have it procured from Bangladesh, okay? So this is a challenge. We have to gain training, acquire knowledge, But you remember that your codified knowledge, becoming a plain simple engineer, doing some routine maintenance jobs, this is not going to stick there for long. Okay, we have to take advantage of our fourth industrial revolution. Read these few slides and then you'll be done. If you have any question, feel free to ask. If not, then we will finish our class right here today. So this is lecture slide 6. And with this, we have achieved the syllabus, covered the syllabus of your midterm. And I have not updated your midterms, your course calendar yet, but hopefully in about 1 or 2 you're going to get this update. As you have seen, I have this broken left arm, so it's kind of amputated me from engaging computers. Hopefully I'll be doing it shortly. Okay, questions? Sleeping?
Sir, if you don't mind, can you upload the whiteboard?
This whiteboard?
Yeah.
Is this necessary?
I mean, it would be nice to have.
It would be nice to have. But you know, I tried uploading this. I tried to convert this into different formats because you cannot upload it in this way. It could be in SVG format or some image format, and when you do that, the size is huge. That's the problem. I could not shrink it earlier.
I see.
I'll try to do it. I don't hope that this is going to happen. I'll try to do it if they can allow to save, export it to some other format. Let's see. It's either image or PDF. If you do PDF, either one of them, it's very heavy. It's very big. That's the problem. I tried to do that earlier. It didn't work. But now if they have some updates, it might work. But I did that when at the time of COVID was there. Saved in the selected folder. Okay. What was it? Untitled whiteboard. Let's see how big is it. Okay, now it has slowed down my computer. This is, okay, I can update this. This is 3.6 MB. Now it's better, okay. I will try to give it to you.
Thank you, sir.
This is how it looks. Is it legible? It doesn't look like.
Yeah, PDFs can be zoomed in. We can.
Okay, okay, I'll give it to you. All right, thank you. Take care. Allah Hafiz.
Thank you, sir.
Allah Hafiz, sir.